Good afternoon, everyone, and thank you for inviting me to present in this great meeting. In the last few years, our groups and others have gained insight on the cause of KLA. A somatic activating mutation in the gene NRAS was found in most of the patients. The mutation is present specifically in the lymphatic endothelium of the affected tissues. Furthermore, we found that lymphatic endothelial cells bearing the mutation have increased survival and proliferation and decreased ability to migrate. However, many questions remain open. Among them, when does the mutation happen? Is it embryonic or postnatal? Which are the target cells? And what are the pathological processes leading to the disease? The zebrafish has several advantages as a model organism to study KLA pathology. It has small size, external and rapid development, and optical transparency that facilitates its imaging. Also, the zebrafish lymphatic systems shares many of the morphological, molecular, and functional characteristics of the human lymphatic system, including the requisite for functional PROX1 transcription factor for proper formation of the lymphatic duct, and the expression of LIVE1, the gold standard marker for human lymphatic. In addition, the development of the zebrafish lymphatic system has been very thoroughly studied and characterized in last years. Therefore, we created two different models of zebrafish to study KLA. The first one has constitutive gene expression of NRAS mutant or wild type in zebrafish lymphatics under the PROX1 promoter. The second one has conditional gene expression of mutant or wild type NRAS in zebrafish lymphatics under the LIVE1 promoter. This model can be induced with tamoxifen. Each one of these models has its advantages and disadvantages. For example, PROX1 is expressed earlier in development. However, it is not lymphatic specific in early embryonic phases. Interestingly, both models show similar findings. At the stage of 2 days post-fertilization, differences between the sibling control and the NRAS mutant individuals are noticeable, as the latter develop edema at the posterior trunk. Continuous observation of the developing mutant phenotype show a progressive malformative lymphatic phenotype characterized by inadequate fluid drainage and bloating of the trunk and tail regions. Confocal imaging in 5 days post-fertilization larva showed distinct differences between the control and the mutant groups, with the mutant group demonstrating clear and large lymphatic cavities and malformed mid-trunk vessels, in contrast to well-formed and well-organized mid-trunk lymphatics in the wild-type NRAS expressing line. The mutant larvae have significantly thicker and bloated thoracic duct. So to summarize this experiment, the expression of mutant NRAS and not wild-type NRAS under PROX1 or LIVE1 recapitulates the lymphatic phenotype of KLA. Interestingly, using the inducible LIVE1 controlled model, we observed a restricted time window in which the NRAS activation induces a dyspractic phenotype. Whereas expression induction by tamoxifen at 24 hours post-fertilization leads to similar phenotype to the constitutive model, induction at 48 hours does not lead to any noticeable lymphatic phenotype. This might suggest that activating mutation in the RAS pathway disturbs the earliest stage of lymphatic system development, the specification of lymphatic endothelial cells from angioblast, and affects only a specific pool of progenitor cells residing in the posterior cardinal vein. Trametinib, a MEK inhibitor, has been reported to improve the symptoms of KLA in patients. Therefore, we studied its effect in our model. Incubation of both zebrafish models with trametinib, starting at 24 hours post-fertilization, decreased the severity of the tail edema and the other lymphatic phenotype in a dose-dependent way. Quantification of thoracic duct thickness showed statistically significant reduction with trametinib treatment. Our current goals include high-throughput screening of known drugs with the hope to identify effective and safer drugs. Also, we would like to identify the molecular mechanism of mutant NRAS in the developing lymphatics. I would like to thank my group at Sheba Medical Center and my collaborator at Weizmann Institute, and especially Karina Yaniv. Thank you for listening.